Yo.
All right, hello, Billy and Carter, and whoever else is watching this. This is the second half of 5-1 notes. Just as a review, on Tuesday, the last time you saw me, we constructed the circumcenter. So just review as to what that even was. Let me erase some stuff. What we did was we made these pink lines. So everybody take a look at the pink lines. The pink lines here and here and here. Those three pink lines were bisecting the side. So if we look at this side right here, we split it in half. And that's what these little tick marks are doing right here. And we made it a 90-degree angle. So those pink lines are bisecting at a 90-degree angle. And they come together to form the circumcenter, which is this dot. Then we say, okay, if I draw that back to each one of the angles, so like this line and this line and this line, those are going to be exactly the same length, right? Now, what is not the same length is like this and this and this. Our original lines, one of them is obviously shorter, correct? Okay, so those are not the same, but what is the same is the back to the vertices. So we bisect the sides and they're equal distance to the angles. Guess what? The in-center, which is what we're going to do today, is like kind of the opposite of that, okay? So here's what we're going to do. We are going to bisect, and instead of bisecting the sides, we're going to bisect the angles. All right, here's how you're going to do it. Ready? We're going to eyeball it a little bit. Okay, we're bisecting the angles. So write that down. The in-center is bisecting the angles. Okay, and here's what we're going to do. All right, we're going to do the top one first. We're going to bisect that angle. All right. It's very hard to bisect the angle by eyeballing it, but this is the best way I've come up with, okay? This is the in-center, yep. So, take a look at this angle right here. You don't have to retrace it, but that's the angle that I'm talking about in yellow. Ready? Here's what I'm going to do. Bisecting means we're going to split that angle in half, and we're going to do it by eyeballing, which is kind of hard to do. What I'm going to do is I'm going to come down here in this area somewhere, and I'm going to mark where halfway would be. Does that make sense? Okay. So you don't want to put it too far over here. That's obviously not in the middle, but go as somewhere where it's kind of ish in the middle. Got it? Now I want to create a line that is splitting that angle in half. And if that's the middle part, I'm going to take and I'm going to connect my vertex to that line. And I'm going to make a straight line. If you still have your note card or some form of straight edge, that would not be a bad idea to get out. But that angle looks kind of like he's split in half. That's not so bad. Right? Good?
Wait, so you
We're cutting them in half. So yeah, I'll do this other side. Okay, so if you're doing this angle down here, I'm going to do the bottom left corner next. Doesn't matter which one you do next. I'm looking at that one. And I'm going to come over here and I'm going to say this kind of looks like he is where he would be split in half, right? And now I'm going to connect him. So this vertex to that point, something like that, is cutting that angle in half. Okay? So that's the easiest way I have found to do it is come out here in the middle somewhere and put where the halfway point would be. Okay, and you're bisecting that angle, you're splitting them in half. And we're going to do the other one. The third one here. Boop, boop. And I'm going to say about there-ish. And guess what? They're supposed to intersect, hopefully. Ha!
Mine do.
They do! Awesome! If not, just make your circle a little bit bigger in the middle because it's, the more you do it, the better you get.
Huh?
So all those lines should come together in the middle to form the
Vertex.
in-center. The in-center. Okay? So those should all come together to form the in-center. Those dotted lines, just like that. Okay? All right. Good? Got it? That's your in-center. Okay, now, real quick, before we move on and talk about some other special things about the in-center, let's do this. I told you that we split this top angle in half, but I need to make some markings on here to show you that it's split in half, right?
Do 1 tick, 2 tick.
So let's do 1 tick here and 1 tick here. That means that those two sides are the same as each other, right?
Yeah.
Okay. Then, let's do a marking down here in the bottom corner to show that those two are the same, okay? But we can't do 1 tick and 1 tick. We've got to do 2 ticks here and 2 ticks here, right? Something like that. Try to make it so that it doesn't look like one full swoop and one full swoop, right? Try to make it somehow so that you have 2 little tick marks there, okay? Now, why do we use 2 tick marks instead of 1?
So you can say that those angles that are cut in half might not be.
they're the same as each other, but not the same as these up here, right? Okay. The third corner, do 3 tick marks. Doesn't matter which angle you do, 1 tick mark, 2 tick marks, 3 tick marks. No. Okay, I'm going to call this angle A, angle B, angle C. Okay, just to name things. I think the other day we called our in-center or circumcenter Z or something. Yeah? Let's name him Z again. Okay, and then we'll talk about some special things. Good? Some special things about the in-center. Okay? All right. Those 3 lines that we just made, those are angle bisectors. We're bisecting the angle. Now, question. Moment of truth. If I look at this length right here in comparison to this length right here in comparison to this length right here, are those all 3 the same?
No, but it is from the sides.
Okay, these are not all the same. This one looks longer, right?
Yeah.
Okay, so we can't say that all 3 of those are the same. But what we can say is this. Ready? I'm going to take Z, and I'm going to pretend this is like an airplane right here, and I'm going to make him straight down to the bottom side, okay? Now, if you are bad at drawing a 90-degree angle, take your note card, and what I want you to do is take your note card, make him like along that bottom side and connect the corner or the side of your note card. Maybe your note card goes all the way up here. Okay, connect this. I'm trying to draw this so that they can see it a little bit easier. Okay, bottom side of your note card here, top side or this side of your note card like here, right? So maybe your note card goes like this. You want to line up your note card so that that dot goes through the side of your note card, and then you just draw along this edge right here to make a 90-degree angle. Does that make sense? With the bottom side, makes sense? Okay. So if you need to use your note card or whatever straight edge to get this to be a 90-degree angle, you want that to be a 90-degree angle. Now, notice that that side is not going to be straight with my yellow line, right? So if your yellow line is extended out, it's not going to be in the same position as your yellow line.
All of them?
You're going to do that for all of them, okay? So I'm going to erase all my stuff. My dotted lines are going to go like this. Straight down at a 90-degree angle to the opposite side. Again, if you need to use your note card to make that a 90-degree angle, go for it. That blue line is not going to be the same like in line path with my yellow line. Do you see that? Okay. Now, if you need to rotate your paper, go ahead and rotate your paper like this guy right here is going to be, I don't know, like this maybe. Again, not in line with my yellow line. Okay, my yellow line was the angle bisector. This is going to be a like perpendicular guy. So no, they're not going to be the same. Okay.
Blue one, the first two.
Then this guy, I'm going to make him a 90-degree angle, so I'm going to put him like this. Again, not in straight in line with my yellow line, but something like that, right? Okay. And he needs to be perpendicular. Okay, so use your note card if you need to make him perpendicular. Got it?
What's perpendicular?
Perpendicular is a 90-degree angle. Yep, perpendicular. So like this side right here and this line right here are going to be perpendicular. You want it to be a 90-degree angle. Okay, you don't want to draw something like this, right? You don't want to connect him back to the side that way. You want to make it a 90-degree angle, okay? All right, so there's the deal, yeah? Now, question. When we did circumcenter, the first half of section 5.1, we made perpendicular bisectors. So I took this side right here and I split it in half and I made a perpendicular. Is this guy a perpendicular bisector?
No.
He's perpendicular. Is he bisecting it? Is he splitting this bottom side in half?
No.
Not necessarily. If this was an equilateral triangle, it would split it in half, right? Okay? So that's how that works. So it is not necessarily splitting this into equal pieces. No, not true, right? It is making a perpendicular though. Okay, now what can we say about this here? I'm gonna call these like WXY. I don't remember what we said. WXY, sure, just like that. Okay. Let's say that that's those dots where he intersects, right? And those are not necessarily the midpoints, right? Not the midpoints of each side. Okay. All right, we said that the yellow lines are not the same, but the blue lines, this distance and this distance and this distance are all the same.
It's crazy. Wow.
Crazy. So like it makes like a pinwheel kind of, right? Those 3 distances are the same. Okay, so this guy over here, we bisected the angles and now we have a point that is equal distance to the what?
Hurts. I don't know.
If we map this dot back to here,
To each line.
To each line, I'm going to say each side. So he's equal distance to each side. Sides, I should say the way that I worded it. Okay? So he is the same distance from all the sides. Okay? Over here it was the reverse of that, right?
Yeah.
We bisected the sides and he was equal distance to all the angles. That's what the circumcenter did. Okay? The incenter is kind of the opposite of that. We bisect the angles and he's equal distant from all the sides. Got it? Okay? So that's what that is. All right, so congruent parts. Which lines, there's 3 of them, are congruent? WZ is one line, okay? So that's this guy right here. WZ, okay? What's the next one? Keep going. You're doing good. XZ is another one that's congruent. And YZ. All of those blue lines right there are all the same length. Got it? Good, good? Okay, let's go answer some questions. Oh, flip over to the back of this page. We'll answer those questions on there. For in center. Okay,
Oh, no.
are you ready to go?
No.
Here we go. In center. All right, so the way that they have them labeled, they don't have them labeled the same as us. They do have A, B, C labeled the same, but they have X, Y, Z, and then they label the in center as M, right? Okay, so what they've done is they've made their bisecting angles, okay, which are the ones that I have in green now. Are those the same length, the green ones that I just did? No, not necessarily, right? What is the same length is this guy, and this guy, and this guy, right? Those orange or yellow ones are the same length, okay? And those are perpendicular to the sides, right? Okay, all right, so here we go. It says, created by, how do we make the in center? What did we do? What did we do? Bisecting the angles. Bisecting the angles. I split the angles in half. And that's how he is created. All right, important facts. The blank is equal distance from, or equidistant from each blank of the triangle. The what? What is this point? The in-center, right? The in-center, that point. That's what his name is, in-center. And he is equidistant from all of the sides, okay? All right, then let's go ahead and put in what is congruent to what. So there's 3 pieces. XM, Josie says, okay, is congruent to ZM, which is congruent to YM. There you go. XM, ZM, YM, those are all the same length. Got it? All right, beautiful. Okay, let's go and do some of the notes. We should be right at the top of the second page. We got done with example 2, so that's where we're picking up at, right? Example 2. All right, now it's going to give us some diagrams and some things about angle bisectors. So here's the deal. We have this angle right here, and this is going to be an angle bisector. How do I know that this is my angle bisector?
Because of the little thing in the corner.
Yeah, because of the little tick marks. So this guy and this guy, that tells me, hey, he's splitting him in half. All right, now, here's the beautiful thing. If I take a dot on that angle bisector and I connect him back at a 90-degree angle to this side, and I connect him back at a 90-degree angle to this side, what do you think is going to happen? They're the same distance. So like this distance right here, if it's 4, this one's also going to be 4. Okay? Makes sense? Like that's equal distance. So it's like kind of making like 2 triangles right here that are the same size, right? Okay, now here's what's not true. They have to be forming perpendiculars, right? Like these have to, like if I do a perpendicular on this side, and then let's say I connect him back this way and don't make him perpendicular. This is obviously longer than this one, right? So it has to be at a 90-degree angle to the other side, yeah? Does that make sense? Okay, so that's what this is saying right here, that this line and this line will be the same as each other, as long as it is bisecting the angle. Got it? Okay, so let's answer some really quick questions. A, first of all, here's my angle. Do we know for certain 100% that this is a bisector? Is that splitting it in half? Do we know that for certain?
Yes.
It's not marked that they're ticked, right? Like one's not ticked, but
41.
the angles are the same, right? 41 and 41, that means that those are the same, right? So we can go ahead and put the tick marks there. So they're wanting to know what XY is, the length of this. How much is that? 7. Okay, gotta be 7. Okay, these are like easy questions. B, okay, it is wanting to know what the measure of this angle is. Okay, now, do I know for certain that this is bisecting? It's splitting it in half.
No. Oh, yeah.
No.
Yes.
Can I conclude that it is?
Yes.
Because
Of the
these
tick
two,
marks.
because of the tick marks, because those two are the same, now I can conclude also that the angles are the same. So this is kind of going back the other direction. So what's the measure of JKL, which is this guy? JKL, what's the measure of that? 37 degrees. Perfect. Okay. C is talking about SP, which is this length here. Now, do I know that this is bisecting?
Yes.
How do you know that?
Because of the things.
Because of the little tick marks that are down in the corner. So, how do I find SP?
Equal to.
Yeah, these two are equal to each other. So 3x plus 5 equals 6x minus 7. Okay? All right, now what would you like to do?
3x equals 12.
Subtract the 3x.
X is 4.
Okay, and add the 7. So 5 and 7 is 12. 3x equals 12 and x is 4. Is that what you just said?
No.
I'm behind. Okay. All right, now they want to know what SP is. So we're going to plug it in here. Now, we got done with this, and Ellie Mangers this morning was like, that's not the one I plugged into. I plugged into the top one. But does it matter?
No.
Because they're both the same, right? It doesn't matter. 6 times 4 minus 7.
Yep.
I know. I'm on a low bat. It's fine. We're almost done. Okay, 6 times 4 is 24 minus 7 is 17. So that's my final answer. That's what I want. Okay? All right, we're on a low bat, so we got to get going. Here we go. Last problem on the back side, the very, very, very back. Here we go. All right, this is where it gets hard, and this is where you have to pay attention to whether it says in center or circumcenter, because you're going to treat them differently, okay? Because this is an in center, means that we are bisecting the angles, okay? So when I look at this diagram, I'm saying the angles are split in half, okay? The angles are split in half. So this angle right here is 32, which means that. Which means that. The other angle is 32. Yeah? So I can conclude that. All right? This angle is 34, which means that.
The other one's 34.
The other one's 34. Okay, now they're going to ask us a question, and I think they're asking for. I'm gonna go down to part B. JAC. JAC is this angle right here. I don't know what the other one is. How do I find what that is?
Because you add 32 and 34. Or wait, no, you take 32 times 2. 34 times 2.
Take a look at this whole thing as a triangle, okay?
Yeah,
Not the individual lines inside. How big is this whole angle right here?
68.
68. How big is this whole angle right here?
64.
64. Okay, 68 plus 64 is 132. How do I find out what this whole angle is? 48, Eli says. So what's each one of these? 24. Each one of those is going to be 24 degrees and 24 degrees. Do you see how that works? Okay, so JAC is 24 degrees. Got it. Perfect. Okay. Now, the next thing that we ask, now that we know all those little angly things, is they want to know JF from here to here. The only thing I know for sure is that this guy right here is 15, and I know this guy right here is 12. Okay, now I'm going to complete that triangle, and I'm going to make him like this, and this is a right triangle.
Pythagorean theorem.
Can you do the Pythagorean theorem to find this guy, right? Because what do I know about this guy and this guy? They're the same, right? So if I do the 12 and the 15 and the whatever, right? So I've got my triangle looking like this, okay, where I've got 15 here, I've got 12 here, and I've got, let's call it X there, right? Which side is your side C?
The short one.
Nope, 15. The longest one has to be your C. So let's do like X
yeah.
squared plus 12 squared equals 15 squared. That's A squared, B squared, C squared. Got it? Am I going too fast?
No.
Okay. X squared plus, what's 12 squared? What's 15 squared?
225.
Okay, and then what?
81.
Okay, minus the 144. Eli says it is 81. So, hey, we like it. Take the square root. X is 9. The square root of 81 is 9. Okay, that means that this is 9. Oh, let me see. Right here. This is 9. Oh, come on. Right here. This is 9. This is 9. This is 9. So that answers my JF question. JF is
9.
9. There you go. So lots of Pythagorean theorem things happening in that. Okay? All right, good? Okay, so you guys have, well, maybe not lots of time because it's Friday. Okay, homework, answer all the other ones. So you should have half of them done from Tuesday. Okay, but do the other half, which are talking about the in-center, and make sure you have this written down that this typo needs to be fixed on skills practice number 12. This should say QPA instead of QPK. QPK is not even a line. Okay, so QPA is what it should say. Okay, fix that, answer all the rest. Got it? Okay, start so you can ask me questions.
Can I go to the bathroom?
Sure. Let me pause this video.
Start.
Ugh.